So in this video we're going to talk about an electrophile versus a nucleophile, right? And we're going to talk about some reactions that includes both, and we're going to identify where is our electrophile, where is our neutrophile. Now let's say we're given this reaction on an exam and we're asked where is our electrophile, where is our nucleophile, right? Which one? Well, an electrophile, I want you to think of it as something that attacks. I'm sorry, excuse me. A nucleophile, I want you to think of a nucleophile as something that attacks, while an electrophile will be something that actually gets attacked. So in other words, the nucleus, nucleus is usually positive. So nucleophile means lover of positive charges. While electrophile, you can think of an electron as being negatively charged, so they love negative charges. So in other words, a nucleophile would tend to be something that gets positive in a reaction, right? The product of a nucleophile attacking would be positive, while the product of an electrophile getting an attack would be negative, right? Now, where does the attack usually occur? The attack usually starts from our electron-rich areas. Now in this case, which one would be your nucleophile, which one would be your electrophile? Well, in fact, this would be your nucleophile because it would actually attack. How do I know this? Right, and obviously then this would have to be your electrophile. So how did I know that this is actually my nucleophile? Well, it is actually electron rich. I know that my nitrogen can act as something that attacks because it has an abundance of electrons. So in this case, in the form of lone pairs, we have it can actually do the attacking. So if we draw a curved arrow mechanism, we could actually see that the nitrogen in this case actually comes, attacks the hydrogen, simultaneously breaking a bond to form a single bond, simultaneously breaking the bond and forming a single bond, forming from the single bond it forms a pair of lone pairs on the chlorine. So in other words, if I draw the products, I have a nitrogen that still has two methyl groups on it, or two CH3 groups, but now it has taken on an additional hydrogen. Now, if you do the formal charge around the nitrogen, you would actually see that it is actually positive. Now remember that the nitrogen, the hydrogen got transferred to the nitrogen, and so essentially we have chlorine in solution. Now this chlorine is actually negatively charged. Why? Because even though in organic chemistry we do not write our lone pairs, initially there was 3 pairs of lone pairs on this chlorine. Now because we've added an extra pair of lone pair in the form of a single bond, now chlorine has 4 pairs of lone pairs. And so the formal charge on the chlorine atom in this case would be negative, right? And so, like we said before, a nucleophile, lover of positive charge, when the nucleophile attacks, it tends to be the positive product in solution. Whereas an electrophile, think of electron as being negative, so lover of negative charges, it is the one that's going to be attacked by a nucleophile to eventually become negative. Let's try another one. All right, see if you can actually predict the products and which one is your nucleophile, which one is your electrophile. So we have a CH3 that's double bonded to an oxygen, and we take that in solution plus hydrochloric acid. Well, my question is, what is the nucleophile? What is the electrophile? Now, again, remember that nucleophile is what actually do the attacking. And so these are usually in the form of the pairs of lone pairs. Right? So in this case, the oxygen, a lone pair on the oxygen will actually serve as the nucleophile. Right? So essentially we could see that this structure will actually be the nucleophile, or in other words, what is going to attack an electrophile and essentially becomes positive in solution. So that means that our hydrochloric acid must be our electrophile. Right? So this is going to come, take off a hydrogen, right? And then the bond is going to break and go on the chlorine. So essentially what we do have is this as the product. Now we have the hydrogen bonded to the oxygen. The oxygen now becomes a positive charge. Why? Because we now have only one pair of lone pair on the oxygen, right? And we still have our original hydrogen plus chlorine, which would be negative in solution. So this is a part in organic chemistry where you have to get comfortable with your formal charges, right? So notice that I didn't draw the lone pairs on the chlorine, but you should know that chlorine at this point has 4 pairs of lone pairs on the atom itself. Let's try one more. Can you identify which one is the electrophile, which one is the nucleophile? Right? We already said that the nucleophile is what does the attacking, and the electrophile is usually what receives the attack from the nucleophile. Right? Now in this case, I'm going to give you the products, right? Because we're simply just identifying. All right, so this is kind of the beginning of organic chemistry itself. All right. Which one is the nucleophile? Which one is the electrophile? Well, looking at the reactants themselves, I could actually definitely see that this would actually be my nucleophile. And why? Because I see negative charges. I know that I'm electron rich in this air, so it's most likely going to do the attacking. Whereas this is most likely, obviously, it would be my electrophile. Right? You can also tell from the products, right? We said that a nucleophile, they're lovers of. So we said that electrophiles are lovers of negative charges. Think about an electron. So an electrophile is something that usually becomes negative in solution after receiving an attack from a nucleophile, whereas a nucleophile usually becomes positive in solution. Think about nucleus as being positive, so they're a lover of positive charges. In this case, CH3OH, or in other words methanol, is not positively charged, but since we know that this is definitely the electrophile, or in other words this is the electrophile, then that must means that this must be the nucleophile. Now, if we draw the mechanism, we can actually see that lone pairs from this oxygen essentially is going to attack. Right? So lone pairs from this oxygen is essentially going to attack this hydrogen, right? And this is going to form a double bond. But now this carbon has 5 bonds, so I'm going to throw this single bond in the form of lone pairs on the oxygen. Now you might be saying to yourself, why didn't the nucleophile took off this hydrogen? And the idea, it is not acidic enough, right? So this is an aldehyde group, which we will learn about more, and that is not really the purpose of the video. The purpose is just to identify, but again, to quickly answer that question, it would be because an aldehyde group is just simply not acidic enough for a nucleophile to take off the hydrogen, right? And so we'll get the product. So that's how you identify a nucleophile versus an electrophile, and what really we're talking about with respect to nucleophiles and electrophiles.